Here are two examples of solving the system of equations with substitution. So looking at example 3, we can see that it doesn't tell you what y is exactly, but it does tell you what y could be expressed as. So it doesn't have like y equals 2, so you can plug it in directly, but it tells you that y equals negative x plus 4. So this part that's circled, it's the same thing as y. So what that does is you can then plug it in to this y in that other equation. And once you've done that, let's see what would happen. So we'll have now negative 4x plus 2y. So 2y means 2 times y. So that means 2 would now times this part that's circle, negative x plus 4, and then equals 2. Now, even though this equation now becomes longer, but it combined the two equations, and it only has one variable, which is x. And we know how to solve one equation with just one variable. So now the problem becomes solvable. So we'll just do distribution. So negative 4x plus, minus 2x, and then plus 8 equals 2. And then we can combine these two x's, they're like terms, so negative 6x, and then we can subtract 8 on both sides so that we can separate the x and the constants on different sides of the equation. So 2 minus 8 is negative 6. So then we'll just divide negative 6 and we get x equals 1. So you can see that how we combine the two equations, and now we have one variable and we are able to solve that variable. So the problem's not done at this point because you're supposed to have x and y for your answer. So what we can do then is to plug this x back in the first equation to find y, because y equals negative x plus 4, meaning that y equals negative 1 plus 4, since x is 1. So y is 3. So the answer is 1, 3. So notice that to check your answers, there are two ways to do it. So one way to check your answers is with the algebraic way, meaning that you can plug back in the x being 1 and y being 3 in both equations to see if they will make the equation true. So for example, the first equation then would be 3 equals negative 1 plus 4. So let's check if that's true. Yep, that's true. And then we check the second one. So negative 4 times x, which is 1, plus 2 times y, which is 3. Does that equal 2? So negative 4 plus 6. And yep, both sides are equal. So that way we can check that this answer is true. Or if you're good at graphing, you can actually graph it. So let's say that y equals negative x plus 4 looks like this, and then the other equation looks like that. So once you graph it on your graphing paper, you'll be able to identify where the intersection is. And if your answer is true, then this intersection would match this answer. So there are two ways to check your answers. Now looking at example 4, which is a challenge example, it is more challenging because look at the equations. Neither equation tells you directly what y is, so you can't find something that you can directly plug in, or in other words, substitute. But you can make that happen. You can find what one of the variable is. So for example, from this first equation, if we subtract x on both sides, we will then get an equation, y equals 6 minus x. So this equation tells us y is equivalent as 6 minus x. So now this one looks like the example we just did, because now you can plug this y in the other equation. So now we'll have negative x plus 4 times y, which is now 6 minus x, equals negative 11. Once again, we are down to one equation with just one variable. So now we can solve it. So let's go ahead and do distribution. So negative x plus 4 times 6 is 24. 4 times negative x is negative 4x equals negative 11. And now we'll go ahead and combine these two like terms. So that's negative 5x. And then we'll subtract 24 on both sides. So then we can move this constant to the other side of the equation. And that would give us negative 35. And now we divide both sides by negative 5 to get x by itself. So we found that x equals 7. And then we'll do the same thing. Plug the x back in the expression for y to find y. So y equals 6 minus 7, which is negative 1. So the answer here is 7, negative 1. And again, you can check your answers. Now, I do want to show that you don't always have to just solve for that one variable. So it happens that here, because we're familiar with the y equals mx plus b form, so maybe, when you look at it the first time, your first instinct is to just get an expression for y equals something. But you don't have to do that one. You can do x first. So let me show you how. So for example, right here, back in the first equation, instead of doing subtracting x on both sides, we can actually subtract y on both sides. So that way, it's going to give us an expression that looks like this, x equals 6 minus y. So that just means when we plug in, so this 6 minus y can replace the x in the second equation. So when we plug in this time, instead of replacing the y, we're going to just replace x with it. So what happens then? Negative x, so negative 6 minus y. So 6 minus y, this whole thing is like the x. Okay, and then plus 4y equals negative 11. So once again, it's down to just one equation with one variable. It's just the difference is this time we're going to solve for y first, and then later plug it back in to find x. So let's see if that would help. So do distribution, negative 6 plus y, and then plus 4y equals negative 11. Combine like terms, and then that would be 5y. Rearrange the constant, that's negative 17. Interesting. Did I make a mistake here? Let me check my numbers. So if you subtract y, kind of can't find out where it went wrong. Can you guys find out where it went wrong? So I had here, if I subtract y on both sides, so x would equal 6 minus y. And then I just do negative 6 minus y, and then plus 4y equals negative 11. When I distribute, I would get negative 6 plus y plus 4y equals negative 11. Oh, okay. That's because I didn't do the same thing on both sides of the equation. I added 6 on one side, but then I subtracted 6 on the other side. That's why. Okay, so I'm going to add 6 on this side to fix it. Okay, so then that means negative 11 plus 6 is going to give me negative 5. Okay. So I noticed I made a mistake because I was about to get a number that's not the same as when I did it in the blue notes, because y was supposed to be -1. So now, after I fix that, y is -1. So it's consistent with the other method. So if you did it right, it doesn't matter which way you do it. The answer should be right. So then x equals, so we're going to use this -1 to plug back in. So x equals 6 minus y, which is 6 minus -1. So that's 6 plus 1, that's 7. So again, the answer is 7 comma -1, and that would match.